In this build series, I'm going to be making this clamp, 10 of them actually, and these are made from wood, obviously. I made these from maple, spalted maple, and that's kind of interesting. It used up wood that I had that I really couldn't use for anything else, so that's also good. And I should talk about why you would make wooden clamps. First of all, you know, if you're into making stuff, that's what you do, and then you have clamps to brag about. Somebody, you know, some non-woodworker comes into your shop and looks at that and says, "Are those clamps made out of wood?" And you say, yes, I made those. I made those with my own hands. You can brag about that, okay? And you can, especially if you make them fancy, right? The other major advantage of it is how light they are. And light doesn't mean that they're not strong. They're not as strong as metal clamps, but they're plenty strong enough for all of your woodworking tasks. They can put on a lot of force, especially if you use, you know, several. And that's the thing, you can put several on there and you can still lift up what you're trying to clamp together because it's not heavy. And not being heavy is you know, the advantage of that you probably don't realize until you use them is that they're easier to use. You're going to reach for these every time over the metal clamps. I can almost guarantee that. And that's because they work exactly like metal clamps do. This piece of cherry, slide it up, tighten it up, and it's there. Untighten it, and ready to go for something else. So, perfect little clamp in my opinion. I know from my perspective, because I've designed and built a lot of clamps, that I can't take this any further. This is actually the ultimate. I'm making 10 clamps, and the wood that I'm using is this maple. However, it's kind of, well, this one's not bad. This one's pretty flat. But a lot of them are really curved, like this one right here. Point is, you get rid of that curve. When you cut it into the shorter piece, you got less of the curve to cut out of it when you try to flatten it. I'm going to bring them over here to the table saw and cut them down close to the width of the bar, which is 1¼ inches. And I'm doing that without any further prep. Like, if you have a jointer, I try not to do all this without, say, fancy tools like a jointer or a planer. I'm trying to do it all on the table saw, you know, to make it less intimidating for people. And but if you have a jointer at your disposal, it's a good idea to, you know, pass the face that you're going to put down on the table saw over it, square up one edge, you know, if you have that tool. In my case, I have the tool, but I'm going to use the table saw anyway. And what I'm doing is I'm putting the concave side, which is the, you know, the cup side, down on the table, and I'm checking to see how stable it is. If there's a little bit of a tip to it, that's not a big deal. If there's a lot, like if there's a real twist here, you take the hand plane, you knock down the corners so that it sits flatter on the table saw. Just a little bit of hand work before you get going. This is from a tree that I had cut down a few years ago, and it's been drying. It started its drying career in my backyard, and then I cut it into boards, and I brought it here into the shop, and it's been drying ever since, and now it's ready to use. That first cut gave me two things. First, it split the piece in two, gave me this blank over here, which is close to the size I need. And it also let me know how much drying stress there is in this wood. And I didn't detect any, so that's a good thing. I'm gonna actually set my saw for the final width, which is 1¼ and I'm gonna make a cut on the other side of the narrow piece and on the piece that's still, you know, rough on the edge. And then I'll adjust the fence again and stand the piece up on edge this time, putting it on that freshly cut edge that I just made, and cut off one side, set my fence to the final thickness, and make the last cut to get these bars to the correct size. I've got all the bars cut. I actually have one extra, one of the pieces wide enough to get another one out of, and that gives me a little bit of room to be selective. So I've got two of the worst ones here, both of which probably will be fine. The only difference is that this one has the knot right here, and this one has a knot at the end. So knots make the wood less strong, especially when you're bending it, which a clamp, that's what happens in a clamp. So I'm gonna set this one aside. As a reject, and I'll go with this 10 here. Now, I did all this on a table saw, like I said. Nice sharp blade. Make sure the table saw is set up properly. The blade is 90 degrees to the table. The fence is 90 degrees to the table. Everything is parallel and lined up properly, and you'll get excellent results that you really don't even need to sand. But I'm going to sand them, and that's what I'll do next. This is 100 grit paper. I use this piece of sandpaper with a block and my shoulder vise to clamp it in there. And I can see that it's a little bit slack. You don't want that. The paper will rip more easily. So to tighten that up, I'm just going to tap it from underneath and drive the block up. This is a good strategy, by the way, to use up the wood that's curved, that you really can't use for anything longer because it is too curved. You know, to take care of that first, to get rid of that first. And this is a good use for it. You're getting 10 clamps out of basically useless wood. I kind of broke one of my own cardinal rules before starting a project like that, and that was to make a list of the parts right here. So I just did that, actually. Better late than never, right? And the purpose of the list is to go through the plans, actually write down how many of each part you need to complete all 10, and then when you have those parts made, like I've got all 10 bars made, you can check that off. Right? I put a little arrow beside it to check it off. You can also scratch it out. But, okay, I've got these taken care of as well. So I can find that on my list where it says, that's the next one down, actually, and put an arrow beside that. I got the rest of the parts cut out, including the spring. I decided to use oak for that. A little bit stiffer, a little bit more springy, maybe, than this maple would be. and I had a small piece that I could use for it, so perfect for that. I also cut out these parts right here, and this morning I started machining them. This is actually the most complex part in the project, and it's the jaw pad. For the cutout on the bottom, that's shown square on the drawing, but I have an 11/16 inch spade bit, so I drilled it out with that, made a nice clean hole, and I'll finish the cut on the table saw. But while I was still at the drill press, I drilled the counter bore in the top. That's 3/4 of an inch, and that has to be deep enough for the nut and washer to fit in there so that they're below the surface and not sticking up. And then when I had that done, I drilled the 3/8 inch hole that goes through for the lead screw to go through. And then it was back over to the table saw to make these cuts right here. I did that with my mini table saw sled, holding it very carefully against the stop, running it through. And this is important. You want to run it right through, lift it up, and take it out before you pull the sled back. A lot of times when you're operating a sled like that, you pull it back, the material comes loose, gets twisted a little bit, and that can cause a kickback. So push it through, lift it up, pull the sled back, reposition it, make the other cut. And this is especially important, the pushing it all the way through part when that piece is loose. You want that outside the path of the blade when you pull the sled back. I also cut out the blanks for the handles, and these can be left square, just round over the corners, whatever feels good. But I like the way they look when they're tapered on the front a little bit. So I'm going to do that on a table saw. I'm just going to make a simple jig to do that. Also, I need to drill a hole in the end, a 3/8 inch hole, to glue the lead screw into, and I'll do that on the drill press before I cut those tapers. To cut the taper on the handles, I just use a scrap piece of plywood and cut it out so that the handle would fit in there. And then I could run it into my table saw to make the cuts on each side. And you can see that I have a holding plate on top, and there are drywall screws sticking down through it so that they grip the jig itself on the right side and the handle right up at the fat end on the left side. With the tapers cut on the handle, I can do some sanding. I can either bring it back to that sanding sheet I had set up before and do it by hand, or since I have a machine, I can use that and save some time. When I'm building a project like this, where I have to wait until glue dries on certain parts, I try to schedule things so that, at the end of the day, basically, I have something that is glued up that has to stay glued up overnight to be strong enough the next morning. And such is the case with the sanding belt that gets glued onto the moving jaw. And the size that I'm cutting it out here is actually a little bit bigger than what's shown on the drawings. What I found after I had this glued on was that it was a little bit too long, so I changed the dimensions in the plan. And you need a really strong glue to hold this on. I recommend epoxy and then let that set overnight. What I'm using here is a very strong version of polyurethane construction adhesive that I completely trust for this type of thing. Next, I need to get the lead screws glued into the handles, and to kind of key it to the handle, I'm grinding a flat spot on the shaft, and that'll fill with glue when I put it together and help to keep the handle from turning. And once again, the glue that I'm using here is that strong polyurethane construction adhesive. I'm putting it in the hole and then pressing the rod. The rod will actually push the glue up around it. And rather than trying to push all 10 in with my hand, I used the Wagom vise on my workbench, and that was a lot easier. And the next thing that I did was I made a very simple assembly jig for the fixed jaw. It holds the bar in place plus the other parts that I need to keep lined up while I fasten one side to the fixed jaw. And then after that's glued on with pin nails to hold it in place, I flipped it over and put on the other side. Then I can use some of my older homemade clamps to clamp up these homemade clamps. There's a cut that I need to make on the moving jaw bottom, and I'll do that on a table saw, again using that same jig that I used before to cut the taper on the handle, except this time I've made a smaller cutout for this piece to fit in, and much the same, I'm using, the drywall screw holding plate to make sure that it doesn't move while I'm cutting it. And when I got all those done, I could glue on the spring and get that clamped up as well. In the meantime, the glue dried on the sanding belt, so I could get that cleaned up. I'm using a scrap of the same sandpaper to remove the squeeze out and also trim back any sandpaper that's sticking out over the edge. The very front of these blocks need a very slight bevel, and the easiest way to do that is with a sharp chisel, or like I'm doing it with a sander. You're really not taking out very much here. With that part done, I can get it glued to one side of the moving jaw. I'm going to do 5 at a time, drive in some pin nails to hold them in place and make sure that the pin nails are not where I have to drill later for the lead screw, and then get it all clamped up. And there's always something you can do while you're waiting for the glue to dry. I took the time to clean up the fixed jaw and cut that angle in the front. This is optional, but it does make the clamp look a little bit more elegant, I guess you could say. And also it'll fit into tighter places. I gave the glue a couple hours to dry in the moving jaw, and now I can glue on that piece that goes on the bottom with the spring. The glue is already dry on that as well, enough to put it together anyway. And the way this needs to be done is that you need to put the bar in as a spacer to make sure that this winds up in the right place. And then you just clamp that up as well and let it dry. You can see that the bar goes in and it can slide back and forth freely until you put pressure at the top of the moving jaw, and that stops it right there. And now that I know that it actually works, I can get the other side glued on and let that dry as well. And then once again, while that's drying, I did a little bit more cleanup on the fixed jaw. I scraped the inside face free of any squeeze out and also flattened it a little bit. And I also rounded over the corners and eased the edges slightly. All of this is optional, of course. But if you're going to put the time into building your own clamps, I believe that they should be good-looking clamps, not ugly-looking ones. After the glue dried on the second side of the moving jaw, I could clean that up as well. I did that by trimming off the squeeze out and the excess that might be sticking out on the table saw. And then rounding over the corners and easing the edges, very much like I did with the fixed jaw. With all the sanding and rounding done, I can drill a hole for the lead screw through the moving jaw. And I've set up a stop on my drill press fence to hold the moving jaw in place while I drill the 7/16 inch hole. And what I'm doing here is I'm using the same setup to re-drill the holes in the jaw pad. I realized that the 3/8 inch hole that I originally drilled was too small, and I changed that on the plan as well, so you won't make the same mistake as me. Next, I can put the T-nuts in, and these have to go on the correct side, and that's the side where the spring is actually glued down and not open on the end. I learned this the hard way, unfortunately, and now I have 4 holes that I need to fill. And the purpose of these holes is for the tangs on the T-nut. And remember I mentioned earlier about not drilling through the pins. Well, I managed to do that with the big bit, but these tangs go right in line with where those pins are. So I recommend relocating them to below that when you're putting this together, if you're using pins to keep the parts lined up. After the T-nuts are pounded in, they need to be held in there with the screw. I'm using a number 4, a very short one. Doesn't need to be very big for this. Just keeps the T-nut in place and keeps it from coming out. Now I can get the handle threaded in, and After that, I can put the job pads on. They go on like this. And then you take a nut and you put that on there, like so. Let's flush on the end. And to hold the nut in place, there's two options. Well, actually, there's several options, but the one that I prefer is to peen it. What I do is I take the nut with the threaded rod inside, I put it on the side of my anvil, the small one I have, and I pound on it until it becomes oval and it stays on the end of the lead screw. It can't unscrew. And that's important because you don't want this to come apart. Another option is to use epoxy. Make sure the parts are nice and clean. Get it on there, let it set. Also, you can drill a small hole through and use a small finish nail as a pin. With that done, I can take some grease. I'm using Vaseline because that's what I have out here. I'm going to put some on the end of the lead screw, and then take the jaw pad and you put a washer inside. And that's why it's important that this counterbore be deep enough for both the nut and the washer, because the next thing need to glue on this, which is the pad. Just going to use regular wood glue and spring clamps to hold it on. I let the glue dry on this pad. Now I can slip it on the bar and glue on the other pad using the clamp to clamp it. I get a little bit of glue on here and spread that around reasonably well and put it in place. Slide the clamp up, try to get this lined up properly and tighten it up. And that's it. I can set that aside, let it dry, and then when it does, last thing I need to do is spray on some water-based polyurethane to finish them, and they'll be ready to use.